I think that if you study a little bit about human behavior, you will realize that we need tangible things sometimes to understand things better, and we need to cluster things. So if you start to think about, to speak about abstract things and philosophy, people get lost, and engineers more.
Now we are back with, this, as Manon described, this trilogy, and we're super excited about it because, as Manon said, we are also in product design, or we're engaged in product development in wearable tech. So we have made quite some experience in what it means to make a wearable device, and we chose this trilogy topic because also for us, we want to learn even more about this. So the title of the trilogy is Think, Make, Scale. And this is meant to, also in a chronological way, a simplified concept of developing a product. So first you might like to think what you want to do, then you make it, test it, and then you scale it. And whether this, this way of outlining a process is correct or not, we are also going to discuss today. And yeah, in wearable tech, you know, in the past we have seen a lot of new products, from smart shoes to smart glasses, but I'm wondering if any of us is at this moment wearing smart glasses or smart shoes. Probably not. So there's a question, why is that? And yeah, markets have only favored a few interesting products. And very often these products now aren't even recognized as wearable devices. We call them lights up helmet or a tracker at your key ring or something like that, but it's basically wearable tech. So they made it to market, and it's a very good sign in my perspective that it became its own product category. So that's cool. But the question is, why is that not all products are successful, especially in wearable tech, and how can we as product developers or as startups or investors, how can we improve our products so they do not fall into the trap of being not so useful maybe to people or not actually used. So wearables are very complex. The development is complex. Why? Because they're close to the human body. That means user experience is super important. Very often wearables are intimate devices. Glasses are very intimate. They form like your face. They should look nice. So you see, it's not only a function. Wearables also need to feel good. And hardware needs to be very efficient, power efficient. It needs to connect to other devices. It needs to be small and durable. The software that also is needed, the firmware that's running on the device itself, but then there's also an app and very often a cloud service. So you have the whole value chain of development, and that makes it complex. And last but not least, as I said, the device also has to be useful. So what does it mean to be useful? Useful, is there a general way of being useful in general, or is it an individual thing that depends on the individual user? This good old example, a bottle of water in the desert is more worthful than a bottle of water maybe here close to your home or something. So that is an extreme example, but maybe use cases differ and depending on target groups, for example. So how can we understand what makes a product good and useful before we even develop, before we go through the whole process of making, developing the software and everything, because that's expensive. How can we make a good concept and maybe also evaluate if it's good before we invest? And this is today's topic, actually. So we want to discuss strategies and tools that help us here in this topic, and I'm very glad to welcome the speakers on stage. So please, everybody, join me here on stage. And we have selected experts from like everybody can join us. Yeah, exactly. Thank you. We have our experts all have a design thinking background, and what design thinking is, what it means, how we can use it. That's the topic of today. But before we start, I would like to introduce the speakers and give them also a chance to introduce themselves. We start with Stephen Ney. He's the Director of Education at Hasso Plattner Institute Academy. And his responsibilities include the development of new formats and new customer segments, as well as forging of an extended innovation ecosystem. Sounds interesting, promising, and I guess Stephen is going to explain us in more detail what that means. Thank you, Stephen, for being with us.
Well, thank you very much, Thomas, and thank you, Manon and Anish, for inviting me here. It's a great honor. Thank you very much. Well, Thomas, you basically said what I was going to say, so I'm going to have to extemporize. The sharing button still isn't available for me, but don't worry about that. I'll just go on. So my name is Stephen Ney. I'm, as Thomas said, I'm the Director of Education at the Hasso Plattner Institute, the Hasso Plattner Institute Academy. The Hasso Plattner Institute Academy is if you will, the commercial arm of the Hasso Plattner Institute, which in itself is one of the leading IT, if you will, research and teaching departments in the country. It is part of the University of Potsdam. Has been as an official part of the University of Potsdam for the last 2 years. Within that, within the Hasso Plattner Institute, you may know, so the Hasso Plattner Institute is about 20 years old, 1998. 98, I always get that confused, yes, 1998. And in 2007, the Hasso Plattner decided, after seeing this weird way of solving problems in small teams with custom orientation, using design principles to solve very, very complex problems, often in engineering. He'd seen that at Stanford, where he was visiting his friend Terry Winograd. And for those of you who don't know who Hasso Plattner is one of the 5 founding members of a fairly small and unknown German software firm called SAP. That was a joke. I think it's the one of the largest German grossing, at least largest German, definitely the largest German software firm, but one of the largest German firms. Anyway, überhaupt. In total, there we are. So Hasso Plattner saw design thinking in Stanford. And he decided to bring that over here because he wanted his students at his IT institute to have that education, to be more custom oriented, to be more innovative. And so I joined them in 2010, and I've been sort of on and off at the Hasso Plattner Institute. My background is a social scientist, so I'm not an engineer. My background is in social science, and in particular, my background is I've always been interested in how societies solve complex and uncertain problems, sometimes called wicked problems. Yes, the one more thing, and then I'll pass on. I think I'm running way over time. One thing that the Hasso Plattner Institute does, whereas the Hasso Plattner Institute teaches students, the Hasso Plattner Institute Academy, of which I am the Director of Education. We specialize in high quality executive education in both design thinking, other innovative approaches like Agile, but also in IT education. And then, thank you. I'll leave it at that.
Thank you, Stephen. It's an honor to have you with us, because Hasso Plattner Institute is very famous also for the design thinking approach and everything. So I don't think not only in Berlin, but I think it's well known globally, I guess. So yeah, thank you. Next is Leire Frances. Leire has several scientific publications in the area of wearables and design methodologies. Sorry. So that's very interesting. And she's also a product manager of Fesia Technology, a scientific-based company of wearable medical devices for brain recovery. And that sounds super interesting and very, very cutting edge. Yeah, Leire, thank you for being with us. Thank you for sharing your time from, where are you now? País Vasco, right?
Yes, in San Sebastian.
San Sebastian.
Yes, in the north. Yeah. So it's raining. We have no sun here. So thank you for inviting me. My background it's technical. This is why I love reading and learning about humanistic and social sciences. So yes, after studying engineering and being in the industry, working for some years, I felt something missing, and I wanted to know how to bring technology closer to people. So this is why I moved to Barcelona to study design. And once I finished my studies, I did my doctoral work in the borderline of engineering and design. And I focused on user-centered methodologies to design wearables. So this helps me to get my current job. I am the product manager of Fesia, as you have said. It's a scientific-based company that design, develop, and commercialize wearables, medical devices for brain recovery. We have 2 wearables, one for upper limb recovery and the other one is for the leg. And the reality is very complex. If wearables are complex, imagine the medical device wearables are more complex. And my role, I have different roles in the company. I have the goal of translating all the user requirements into real products and scalable products. I am very lucky as well because I have the perspective view of all the process that helps me to understand how to communicate products, not only communicating, but designing and just having all the perspective. And I am very happy to be here, and I believe we will have a very interesting event here with the experts and with all the people that has come.
Thank you, Leire. Great, nice. Then we have Carlotta Kelbel. She's a design thinking coach and textile researcher at ITA, RWTH, RWTH, Aachen. And Hannah combines knowledge from engineering and science, also with design methods and vice versa. And she helps startups, companies, and institutes to innovate through agile prototyping. Very interesting. Prototyping is our next topic in the next event, but maybe it's hard to differentiate from design thinking. I guess that's what you're going to tell us. And I'm really looking forward for discussing also this. So yeah, Hannah, the stage is yours.
Thank you, Thomas. And it's really interesting because I have 2 connections to Stephen and Leire. The one is that I've been also to D-School for Design Thinking in Potsdam, which is close to Berlin. And on the other hand, I'm also a trained engineer, and I kind of got to design through positive incidents, I would say, because, and that's what I want to start with as well, is what I've learned from Professor Bill Dresselhaus 4 years ago when I joined Hongik University in Seoul, South Korea. And Professor Bill Dresselhaus was actually a first student at the D-School in Stanford, and he told me that every design can be user-centered. It's not a design or a designer privilege. It's also a tool and a method that everyone can apply to design. So I took this mindset when I went back from Seoul to Germany, and I asked myself how I could implement this idea into my mechanical engineering research. And the interesting thing is that I found a material to do so. And the material that I'm working with, you can see it, and I'm trying to share my screen in this picture. And what I found interesting is that Stephen said, oh, you designed an apple. But, and then that's the interesting thing, design thinking, this is what you see if you talk about design thinking, because the story behind it is that there are many people who can't grasp things anymore due to different diseases. And what I thought is, why don't I start with this problem and design the material that I'm investigating around it so that it could solve that problem. And then prototyping comes in, but that's something we can also discuss later. So what you see here is then the result of following the design thinking process from understanding the problem to actually designing a material, and in the end also a product to help people grasp again. And with that, I can talk a lot more, but Thomas, you already said what I'm working on, so I'll give back to you, and looking forward to our discussion.
Thank you, Hannah. Thank you for the cliffhanger. So now we can already start with the discussion because, I mean, you showed us a picture of the Apple and the device that you designed. Let's start with the basics because maybe some people in the audience, they don't know what design thinking is. And let me ask you a very simple question. What is design thinking? Maybe you can take it from your example with the glove. Like what's the part of design thinking in this project?
The part of design thinking in this project is that I first found a complex problem, and I further investigated this complex problem, and that's part of the design thinking kind of methodology. So first you find the problem, and then you try to find solutions for that problem, or first you find ideas how to solve the problem, you test them, and then you transform them into a solution. Yes, that's what I would say is design thinking, but I guess, Stephen, you can add on this.
Yeah, I can. Yes. So design thinking is amongst other. One can approach design thinking from many different angles. Yeah. So perhaps one should start with what are the constituent parts of design thinking, or what makes up design thinking. So it is, as Hannah says, a problem-solving process. But like all problems, as a problem-solving process, it's not particularly different to other problem-solving processes that you may know. That I, for example, as a policy public management person, know from decision-making models. It's quite similar. What makes design thinking distinct is the fact that it is very, on the one hand, it's a problem-solving approach that leverages the pluralist different perspectives that a small diverse team of say 5 to 8 designers, but I'll put designers in air quotes, that 5 to 8 designers in a small team, you leverage the different perspectives on a complex problem. So what I mean with leveraging different perspectives, and I think this is where the difference is between other problem solving approaches. What you do in design thinking through a whole host of different methods and different approaches and methods and ways of going about things, practices, is that you take a team of an interdisciplinary team. So I'm in a university context. In a firm context, interdisciplinary may mean cross-sectional across different functional areas. But say in a university context, it means interdisciplinary. That means you take the engineers like Hannah and Leire, but then you take someone like me, who is a social scientist, but you might also take an artist. So Hannah will remember from her time at D-School that she worked with biologists, with mathematicians, with IT people, which are the majority at the HPI, but also with artists and musicians and designers. So what you have is this different interdisciplinary take on things. And what you do is you have a problem-solving process. But what you try and do is you try and take a complex problem like disability. I think that's what Hannah, basically a problem is how might we question, sort of a technical aside here, how might we provide tactile senses to people with disabilities or with diseases. And that is a complex problem. It's not just an engineering problem. It's a biological problem, but it's also a social problem. So how do how do you help people reintegrate into society because they have lost the sense, etc., etc. So I think that's one thing. There's a problem-solving process. There's diverse teams, and then the third thing is a very important thing, and I think I'll pass over to Leire, but I'll just say it, is is user orientation. Yeah, the important thing is that what we try and do is we try and understand everything through the eyes of the user. Isn't that right, Leire?
Yes. It is very interesting what you were saying. Just let me add something about the interdisciplinary team. For example, in our case, as it's medical device field, we have to design with clinicians. So we have to take them into account. The common error or problem normally is that engineers think that they can solve the world without taking into account other experts. And this is one of the keys of having success for me, like taking clinicians, taking engineers, taking designers, taking usability experts, a team, an interdisciplinary team working with the same goal or with the same purpose. And about the same thinking, I would also add one thing that is very important for me. Depending on the culture, I think, and in the industry, here, for example, as I was saying before, we have a lot of industry. There are a lot of machine tool companies. So everything is to do. And every stage is very convergent. So we are not used to think open. So we are not used to have divergent phases. So it's very interesting in the design thinking, like being aware that where you are, if you are in a divergent phase or in a convergent phase. And putting on the jacket of okay, I have to be open or I have to frame the problem. And I think it was one of the most interesting things that I learned when I studied design thinking.
And adding on that, maybe just as a last note on that, this makes the process a learning process. So through the iteration that you do, which is really important part, and it's that you do divergent and convergent phases over and over, but the learning outcomes that you make, that's kind of the profit or the benefit that you generate throughout the process to generate solutions for these wicked problems.
Okay, that's a good point, but I think I have to dig a little bit deeper here. What is divergent and converted? Can you explain a little bit more what that means for people that don't know? Leire or Hannah?
Okay, it's difficult to explain by a definition, but for example, brainstorming, it's a divergent methodology. So you have to think big without framing. You have to define a question, for example, that you should answer, but you have to eliminate biases, eliminate eliminate. The most important thing is the quantity. You have to generate a lot of ideas. If you make user research as well, this is a divergent phase. So the more important thing is to get a lot of information. And then an example of convergent phase, for example, would be clustering things, framing the problem, defining a design brief, for example, service blueprints, for example. I don't know if Steven or Hannah want to help me a little bit with more examples.
Oh, it's me then. All right, fair enough. Allow me. I'll show you a slide. It's in German, but don't do worry. Oh, that's exciting. What have I done?
I will show you something in Basque later. Don't worry.
That's very good. So, can you see my screen? Can everyone see my screen? Or
yes, we see your screen. You see your PowerPoint interface.
It's a PowerPoint. Okay.
Yeah.
So this is in German. Basically, what you see here is the 6-part design thinking process. It's only one part of the process. This is what we use to teach This is what we use to teach people design thinking. And you can see that some of these phases open and close. And as Hannah and Leire described this, basically you can think of the design thinking as something where you open up possibilities, yeah? And once you have loads of possibilities, you then choose one or two, and you do that through diverse different methods, and then you open up possibilities again, and you diverge and converge, and through that divergent and convergent movement, you move. It's also cyclical in a way, so it's divergent and convergent, but also cyclical. You move slowly but surely towards I won't say solution, but so complex problems are never solved at the end, but you converge and diverge. By diverging and converging, you converge towards a solution. And the point of this is that, as Hannah and Leire rightly pointed out, this is not a process that is finished. I know that sounds a little discouraging. It's a learning process that is always ongoing, and that's the important thing. So what a lot of people that come to the HPI Academy think is they'll learn design thinking. And this is reminds me a lot of some of my PhD students as well. You know, they learn this method and they plug in the problem and they do it all. And at the end, boom, after 6 phases, there's a new iPhone. Yeah. And that's just not how it is. It's basically a process where it makes hard things really easy. And the hard things are the divergent, the convergent, the always going back over the solution and getting hard feedback from your users. That's the really important thing. That's what drives this. Feedback from the users, always better understanding the user needs, always better understanding your solution, and sometimes having to pivot as they like to say. And that is basically the essence. That's what Anna and Leire are expressing, is the essence of this movement. Design thinking is not linear. It's a movement that goes like that, but it also circles, and that is a little bit daunting. But the nice thing about design thinking, it takes this very, very difficult process and makes it fairly fun and easy.
So you said something very interesting. So you have to test the result or the hypothesis with the user or with the people that you want to help or support or solve their problem. So where do you integrate them in the process? Are they already part of the team that's developing the ideas? Or is it like a team of experts, so to say? Yeah, we're talking about designers and artists. It sounds like experts to me. It was like biologists, and they come up with an idea, and then you throw it at the customer and see what sticks. And then, like the spaghetti, the spaghetti principle, you throw them in the wall, and then you see what sticks, and then they're ready. Is it like that, or is the customer part of the team? What is something that's best good practice?
That's a vexed question, Thomas. It depends. For example, in our case, we have 2 kinds of users. We have a lot of kind of users, but some users are clinicians and other users are patients. So we have extreme users. If we are designing for patients, we have to take them into account. You have to understand that they have suffered a stroke, they have multiple sclerosis, sometimes they have cognitive problems, they have emotions. It's very, very, very complex. If we design for clinicians, it's easier because we have clinicians in our structures, we have people that speak the same language as them, so it's easy. But when we design for final users, for patients, we have to have them into account, of course.
Building on that, you mentioned already interviews as a technique to integrate your users from the beginning. You can also do immersion, what would be put yourself into the shoes of the user. It's a very different perspective. You should never say, I do immersion so I know what a user thinks, but it helps you to define your personal perspective on it. And then later on, you have to integrate them. And then it comes, like you said it already, Thomas, the kind of what is prototyping in design thinking. because at the moment that you reach the solution space, and that's the second part that Stephen has been talking about from the diverging, converging phases, is that you design prototypes from every stage of, like, from low fidelity to high fidelity, and then you test them with the user. And the results of these tests help you actually to decide where you have to iterate on your idea or your problem. This might also happen. So the user plays the role of helping you making decision somehow.
But just to add to that, if I may, as I say, it's a vexed question. That's a very British way of putting it. It's not this has not been decided. There is no consensus on this, and of course, design thinking is not we don't have a fixed canon of methods, and design thinking is a very flexible sort of term that covers a lot of things. Also, design thinking is very close to transitional design and participatory design. Actually, these are cousins of design thinking. And you can think of, Thomas, so one thing that I always argue is that what design thinking does, it is a participatory method. And that goes back to my previous life as a political scientist. I looked at participatory citizen involvement. But design thinking is a sort of participatory method. And it provides a voice of the user in the design process. Now you can decide, as someone who is setting up a design thinking team or project, you can decide how close the user is going to be. Yeah. And it all works. It's all design thinking. So you can have the user's voice vicariously. That's a very silly English word, but you can have the user's voice. You can go out and get the user's voice and represent them. Or you can have the user in the team. Now, me being an old lefty, I'm saying always have the user in there. Even, and I'm sure, Leire, it's not so easy if you have people with brain damage or but still, why not have them as designers?
For example, we have. Sorry.
No, go. Please, Leire, you have.
So recently we are medical devices manufacturers, but we have opened a clinic. It is a small clinic, so we have patients with us now. So it's a chance of knowing them better. Yeah, so it's not our business model. It's not our business model. We don't want to have a lot of patients, but we saw that we need to understand their needs better.
Yeah, and so there's many instances in which you could imagine, and for wearables, I could imagine that you could have your users as part of the design team. I mean, it makes sense. Yeah? So both works. Either you have them as you throw it and it sticks, or you have them integrated. And that has pros and cons, obviously.
That's very interesting. And I have to, I think me as a moderator, I want to find the borders and maybe also the challenges of the design thinking process, because I'm a fan of it. But I have learned that it's about complex problems. Maybe it's also about problems that I personally, as the product owner or designer, I cannot fully understand. I need the help and support of others. And that brainstorming, for example, is one of the tools that can go into the whole design thinking process. So there's different tools, and all together makes design thinking. And then what Hannah said is, by prototyping, as far as I understood, you can test your idea. You have to prototype, right? And I think that's especially now talking a little bit closer about wearable tech. I think that's especially important for wearable tech. Also, yeah, Stephen said it, that with patients, maybe that's very important. Can you elaborate a little bit on the role of prototypes and why our trilogy is not correct?
No, it
no. I'm just joking. I think I already know. So we talked about this before, but so yeah.
I could start with what I've always think is a really nice example, and it's a little test to the audience and you as well. So there's this little warm-up that we do. Please think of a dog. Do you have a dog in mind? Okay, so which dog are you thinking about?
A spaniel. A spaniel. A black spaniel.
Okay. What is your dog, Thomas? What
It's a poodle.
It's a poodle. Okay. So what you learned right away is that you talk about things, but they might mean different things to people in the room. And prototyping and different stages help you to get a common understanding of words or sketches, scenarios, whatever. They help you to get a common understanding both in the team, but also with the users. So in every stage that you want to get more concrete, you will need them. And then you have, as I said already, different stages. You might want to have first a low fidelity prototype, which could be a sketch, a little sketch, a drawing of what you're talking about. And then in the end, it could be something that you've seen in my picture that is still a prototype because it's not fully functional, but it actually is wearable. You can use it and you can ask people actually certain questions that you want to clarify in your process, whether it helps them, whether they like it. There's many questions to do so.
Okay, great. Leire, I think you are also working with a lot of patients. Can you give us a few insights into your work and how you use these methodologies to develop your products?
So it was very interesting was that Hannah was telling. I think that if you study a little bit about human behavior, you will realize that we need tangible things sometimes to understand things better, and we need to cluster things. So if you start to think about, to speak about abstract things and philosophy, people get lost, and engineers more. So you have to make it easy for people. In our case, for example, I would say, and this is related to my doctoral work, that you can think in wearables about physical ergonomics, cognitive ergonomics, and emotional ergonomics. Mm-hmm. So in our case, the wearables have three kinds of ergonomics. So you can, for example, we have an upper limb wearable. You can make your textile in a low fidelity textile, but you can test if sizing it's proper. You can test as well if the velcros are working properly, and you don't need to develop the software part. You don't need to develop all the electrodes, all the electronics. So it happens that you develop everything and you only test when you have finished all the development. And then you have invested a lot of money and you will have to do it again, because scaling everything and making new dimensions make you change everything. So I think that you can start to test from the very beginning, and the sooner you start, the better results you will get later, and you will save money. So this is an example, for example, and on the other side, I could put the example of the software. You can also make a software without making it. You can use Immersion, you can use a Sketch, there are a lot of tools that you can use to test only the software. So you can be testing two things of the product at the same time, for example. It is very interesting for a company being able to do these kind of things. I don't know if I have answered the question or not.
Very good, very much. Thank you so much. So in your opinion, the end user, the client, they have an understanding, like, because it's a little bit abstract. If you tell them, for example, this is going to be the app, and here I want to have the button, and if you click here, then you see all your data, but then you can go back here. You know, like if I think of a paper comic style app that I do very quickly with a few things that I can move around, and I want to test with my clients what they like or not. In your experience, are they the people, the users, are they capable of doing this abstraction, or do you need to do something on a screen so they understand, you know, or is there something that's interesting?
Yes.
Or
it depends. For example, paper-based prototypes, we can use them internally in the company. I can use them with the commercial team and the technical team in order to make decisions. But then to the user, you have to change the communication drastically, and in our case more. So you have to observe them, just how they interact with the prototype, and they will give you a lot of ideas. I think that the goal is different. If I had to test a software application, I think that I would ask for key opinion leaders to ask of the content. And then if this application will be used by patients, for example, I would invite some beta testers to test, but not paper-based prototypes. Mm-hmm. In my case, with patients that, yes, in my field, I mean.
Very interesting. I learned something new, not only asking them if they like it, but watching them while they're using it.
Thomas, it all depends on what,
yeah.
It all depends. So I don't have nearly as much experience with actual prototypes. I just teach them. But the important thing is here what you want to find out. Yeah. So paper prototypes are super effective to create a conversation with a user. Yeah. So basically you jot down a couple of ideas, a storyboard, or you have a paper prototype of an app or whatever, and that is nothing but a conversation starter. Yeah. So you take that to a user and you say, look, we've had this idea, and you're talking about the idea on this. Yeah. So what basically you're firing their imagination, saying, look, we have this idea and it could look like this, and what do you think, and how could you change it, etc. But it becomes very different, as Hannah, and this is particularly important for wearables. That won't give them a feeling of the experience, or an experience of the feeling, yeah, of how it feels to wear something like this, or have glasses on, and how you look. Yeah. So some intellectual, as you know, sometimes you buy something online or you see something in the shop and then you put it on and you go, oh, that was a bad idea, because you don't feel right. Yeah. And those are different levels of prototypes, and then you have to have them wearable. But even then you don't need the function necessarily. So it depends on what you're wanting to find out. But as Leire says, you can catch a bad idea very, very quickly, with a paper prototype. Yeah. If we have time, I have a funny story about this, but if we have time.
Thomas, we can't hear you.
Yeah, sorry. Yeah, we have. I mean, we have a few minutes. I was doing a workshop with marketing experts, the marketing people of the Austrian Post in Vienna, and they wanted to do. Yeah, this was a couple of years ago. So personalization and digitalization was all the thing. And what they wanted is a way of marketing. Of direct marketing, yeah, and wouldn't it be great if someone walked down the street? This was their ideation. Someone walked down the street and they could see on a billboard in public space. They could see, Thomas, you like football, so football shoes cheaper just for you, yeah, in public space. And I sort of thought, okay, let's test that. So we set up a small test with an iPad on the one hand, and one person sat at the corner and they interviewed these people and they said, what's your name? And they said, my name is Gustav. And Gustav, what do you like? I like skiing. And then they recreated that poster sort of on an iPad at the corner. And they thought this idea was wonderful. Yeah, wonderful. And guess what everyone said? Can you guess? Yeah, so they walked past and they held up, hey, Gustav, skis cheap. What do you think people said? Oh my God.
Yeah, they said scary. No way would I want my name on a billboard. And that took about an hour. Yeah, just coming up with that prototype and testing it. And they would have gone for this, and they would have allocated budget, and they thought it was such a wonderful idea. So I suppose what I'm saying is that even very, very simple prototypes are a way of testing your assumptions about your solution. Mm-hmm. And this is what design thinking also is. It's also, yeah, so there's a lot of movement. Another movement is I set up assumptions about my user and solution, and then I go out and test them. And an idea is just an assumption about a solution. Yeah, we think as a team that this will help the user. So you set up the assumptions, then you go out and test it, and then you learn. As Hannah said, it's a learning cycle, and it's quite painful. It can be painful. That Austrian team wasn't happy with me.
But That's maybe why they pay you, because they
never invited me back.
If they're really unhappy, that means you were right, because there's nothing to say against it. So let me play devil's advocate a little bit, because I said I'm a fan of design thinking, but let me ask you this question. Back in the days when the car was invented, when you ask people, what do you need? They would have said, we need more horses. If we want to go faster, we need more horses. That was the way of thinking. They could not imagine a car, a horse wagon without a horse. That was not part of their horizon. That was something, and also the glibbery, dark liquid coming out in their backyard they didn't know what to do with it. Later it turned out it's oil, right? But back in the day there was no use for it. So there's this visionary moment that is there, but how can you get a visionary drive if you're asking people who are not necessarily part of your vision, what do they want? Because maybe they would say, I need more horses and not no horses. And why do you need no horses? We have already, like, here they can drink, here they can eat. With your idea, we need to build something like the whole system of gas stations and everything. Isn't it very complex? No, let's stay with the horses. That's what we want.
But perhaps that would have been a good idea to stay with the horses.
Yeah, looking back, yes. but so you, as I said, I want to play devil's advocate. But do you think there's a limit of design thinking, or is there a methodology or some tool where we can go past that moment?
I combine that answer with a thought that I had for the previous discussion. The first thing is that's the reason why you need a team, the diverse team. Because what users tell you is their personal point of view, how they tell it. And you have the team to identify the need behind what people tell you. So what you usually do in the process, you collect all these sentences that people say, and then you have the team to analyze them. And that's actually why you need the prototypes, is because you're not always fully sure what was the need exactly. So you build these prototypes to actually understand whether you found the right need to develop an idea for. But what is interesting, or in addition to what we've been talking about, is that, and that's you said that wording in the beginning, agile prototyping. I think where kind of design thinking might not end, but turns is kind of has a second phase, so to say, is when you go into the solution space and you go into implementation. And because we have also had this word agility already, so agility is more kind of the headline of all this, and design thinking is one part of executing agility. But when you want to go into a implementation of your idea, you go through other methods, but you don't left design thinking behind you, but you shift your focus a little bit on the method side. So people might know Scrum or other techniques that help you implement them. So you kind of shift your focus a little bit, and then you apply different focus of your method to your problem.
Great. Okay, I get it. So there's also other tools, or there's brothers and sisters or methodologies that rhyme to design thinking that can also help there. And also what I got out of it, it's more like problems definition, and not like that's also part of it. So
yes.
Okay,
you define
great.
the need.
The need.
Yeah.
And then you also have experts in your team to define solutions. Great. I have one more topic or question, because it comes out of our experience when we work with clients. And I think that's very interesting, and maybe not only special to wearables, but maybe a lot, because people come up with a technical solution, let's say a new type of textile that has certain properties, and they're looking now for a use case, which is basically, as far as I understood, not exactly what design thinking would do, because you come up with a problem and then you try to find a solution. But they have a solution, but no problem. How would you work with these innovators or these clients? What is your strategy here?
So it depends. I think you can have, for example, a technology. In our case, for example, we have FES, functional electrostimulation. You have also the problem, because there are more than 15 million strokes, only strokes in the year. But then you have to match your technology with your real problem. So it's a kind of having the solution, because you have the technology, but you have to adapt all this technology to people. So it could happen. When I was studying in Barcelona, for example, we did like different things and different funny things, and sometimes we started by a smart material, and we had to find the problem that could be solved with this material, and you will finish in a very different point. So it's funny as well to have this kind of different approaches when you are being creative in a process.
What you would usually do?
Thomas, you should unmute if you want us to hear.
Thanks.
We're not
finally, after 19 events, that's what this button is for. No, thank you so much. I wanted to ask you, like, there's this phenomenon, like with a hammer in your hand, every problem becomes a nail. And how do you, because that's really an issue. Like, you have something and then you like, okay, I could do that. That. How do I know where to look for a problem? Because it's maybe you can put it everywhere, Okay, Stephen.
So there is also a mindset issue here. So if I know this, I know this from social science. If you have an approach, you have one approach, you go looking for it's a solution, looking for a problem. You have that a lot. I think that's, if someone's got that mindset, it's very, very difficult. But I've worked. Last 2 years I worked for T-Systems, and there's people with IT technologies, but they're really open. And one way of doing that is the design thinking process, as we showed you, starts with understand, ends with prototyping. But you can flip that around. Yeah. So if someone has this idea, you say, okay, let's do loads of different prototypes. Just brainstorm. What could you do? Loads of different prototypes, and then you go out with these prototypes and you give it to users and you see what they do with them. And you try and learn from what users do, basically workarounds. Do they use it in the wrong way? Is that interesting for you? And you just flip that around. And as I say, I wanted to say that last question, let's not be too religious about this is design thinking and this is Scrum, and these things have fluid borders. Yeah. The important thing with design thinking are the movements that Hannah and Leire, the divergent, convergent, the iteration, the learning. Yeah. So if you're doing that, then and you're starting with prototyping, that's fair enough. Yeah. So if you have someone who has this technology, the best way and if they love it so much, the best way is, okay, let's have a couple of use cases and go out and test them, and then you'll learn. That's a really good way of going about it.
It is very interesting what you are saying, Stephen, because, for example, in the reality of a company, we have a technology, we have a solution, we have our target users, but we have to think as well in the future. So we have to think about diversification, the market. So the starting point is different, because we have everything done, but we have to think about growing more and more. And when we do this exercise, we are jumping some steps and we are starting by the final steps. So you are more designing maybe a business model or an adaptation of your product. You are designing another thing, but it's very interesting starting for other stages as well.
Yeah, absolutely.
Super. Hannah, do you?
Yeah,
want to add?
Stephen and Leire had already like the right points, I think. What I would like to add is that you, and then especially kind of, if you have designed your material or your solution for a certain product, the first thing that you need to do is get rid of the product idea. As a mindset change in that moment. And the second thing, what I like to do then is you have a look at the functions of the certain material or whatever you have developed, algorithm or what, and use these functions to do a first ideation on where that could be, and then build the prototypes that Stephen said or mentioned. Because on that level, it kind of leaves the certain material or algorithm, whatever, and it takes it one level higher to a function level, which is easier.
Nice.
We did a lot of use case prototyping using design thinking for 5G use cases when I was at Telecom, obviously. How can you use 5G? And it was really quite instructive.
Yeah, I mean 5G, like you can do a lot of different things, I guess.
But what
so
exactly?
I
mean, that's you can do everything. Yeah, but
everything. Yeah. Wow. Okay. Thank you all. We're almost the time is almost over, but I don't like to let you go without this one question, because you have been working with a lot of different and interesting clients and human beings and people and individuals, Stephen, Leire, Hannah, so many different people, and they all explain to you their problems or the new technologies, and you really have to think with them, and you have to be empathic, and you have to think about the future. Leire has also said it. So I would like to know from you, from your personal experience out of all of this, where do you see the future heading? What is the next big thing besides like artificial intelligence and mobility and so on? But what do you think out of your experience? What is something interesting, one facet of the future that you have identified that you think this is something coming up? Who wants to go first?
I can go first.
Yeah, Hannah.
I think that's something we haven't mentioned yet in this discussion, but previously. The idea of integrating the planet into the process. So considering also planet needs somehow, whatever that might mean. And in that case, I think the future, and it's also something that I research, is that we create things that do not use energy or do not need additional energy anymore. So everyone who wants to look into 4D materials, so everything that has stored the energy in itself and doesn't need any external energy anymore, I think that's something where we will find interesting variables in the future, but also solutions that help us solve planet challenges that we have in regards to the planet.
Super, thank you. Stephen.
So this is nothing new, but I think this is very relevant. If you read all the business commentary, McKinsey, whatever, they're all talking about resilience as part of the COVID. But I actually think, for once, I actually agree with them. I think they're right. I think what we will be seeing is we'll be seeing a huge innovation drive towards making our systems more resilient, because we saw with COVID they're not very resilient at all. And that starts with global supply chains at the big level, right down to how is our interaction. I mean, look at us now. Usually we'd be doing this sitting around with our audience, and now we're talking to a screen, as pleasant as it is with you guys. But I think what we'll have innovation towards resilience, and wearables, of course, a huge factor. iWatch and iWatch. They're a huge factor in creating resilience and flexibility and allowing us to deal with changing circumstances very quickly. And I actually think that's where the innovation will go, because COVID is just the beginning. Sorry.
COVID, hopefully it's over, and then it's the beginning of a good innovation phase.
Yeah. Climate change is coming.
Oh my God. Hopefully we have learned something. Okay, thank you, Stephen. Leire?
Yes, maybe I could add the fact of the aging population, that it's related as well with both concepts of Hannah and Steven. On the one hand, the aging population, so it's real. We have to do something with this. And for example, I would like to be able to teach people how to use the devices without having to move physically, so that you are in the same time being more sustainable and etc. There are a lot of things to do. I think that we are not aware about the aging of the population. It's a problem that we have to think about, and now with the COVID.
Leire, I'm very aware of the aging of population, trust me. I'm very aware of my own aging.
Yeah, aging is a future topic for everybody.
Yes.